The main focus on this video are the three multiplication properties for exponents. We'll start by differentiating between our properties when we have two bases versus one base. Recall that when we have two bases, like x to the 6th times x to the 8th, or x to the 5g times x to the 2g, that's when we add our exponents, and when there is one base but two exponents, we multiply. That's examples like x to the 3rd to the 7th. The base of x only appears once. Here, because I am adding my exponents, I take my x and I add 6 plus 8, giving me x to the 14th. Don't be intimidated when I put variables in there, because we're treating it the same way. This is x to the 5g plus 2g. Those are like terms. If my terms are like terms, I can combine them. 5g plus 2g is 7g. In the problems over here, it's one base. You multiply your exponents. You keep your base the same, and we get 3 times 7 for a simplified expression of x to the 21st. Here, keep the base the same. I have another variable up here, but that's okay. It's this exponent of 4h times this exponent of 6. Because it's multiplication, I can go ahead and multiply all of that. 6 times 4 is 24, and I can just keep the h in there. With that quick review, go ahead and try these 4 exponent problems. Simplify so you only have positive exponents using the two multiplication properties we've just discussed. So for number 1, it is all multiplication. I can multiply 2 times -4 to get my -8 and multiply y to the 5th times y to the 2nd. Two bases, y appears twice, I add my exponents. I get -8y to the 7th. In number 2, the base appears more than 2 times, but that's kind of the gist of the whole idea. If it's more than once, then you add all your exponents. 12 plus -3 is 9, plus there's a 1 there, is 10, plus -2 is 8. 3 and 4 we do have to do in 2 steps, because I do want to consider that I have to simplify this part here first. X to the 4th to the 3rd gives me my x to the 12th. Now I have two bases, I can add my exponents. So this is an example of combining the two properties listed above. This is the same examples, just I've switched the order. But I'm raising y to the -5th and to the -2nd. Multiply -5 times -2, I get positive 10. Now I can add my exponents because I have two y's. The last property we talked about with multiplying exponents was raising a quantity to a power. When I raise a quantity to a power, I have to raise every term to that power. And it's really every term in the parentheses. Now, keep in mind, it is a quantity, which is a word that means multiply. This does not work when I have addition or subtraction inside these parentheses. So our examples of this is parentheses here raised to the 3rd power. Well, that means that every term in here, the x, the y, and the z, have to be raised to that same 3rd power. That's the exact application of this property. Now, what if there's a number in those parentheses like this example? We do it the exact same way. The 2, the q, and the r all get raised to the 3rd power. The only difference being here is that I now want to take this number and raise it to the 3rd power. So use your calculator if you don't know how to do it in your head and type it in. 2 to the 3rd power should give you 8. So I want to simplify any of those numbers. q to the third power r to the third power gives me my final simplified solution. The example up in the top right is different because it already has exponents inside the parentheses. That just means I need to put parentheses around each of them individually, and I'm still raising those to the fifth power. So now it's another application of one of the problems above, where I have one variable raised to 2 powers. I multiply those exponents. 3 times 5 is 15. 4 times 5 is 20. There's my simplified solution. What about this negative? You must put that negative in parentheses, both on paper and when I put it in my calculator. If I don't put that negative in parentheses in my calculator, I run the risk of making an error in my final simplified solution. Here, I have negative 2 times negative 2 is positive 4, times another negative 2 does give me a negative 8. But if my exponent were positive, I should be getting a positive 8, or a positive 16, or a positive 4. So be very careful with your positives and negatives. In this case, it's a to the first to the third. 3 times 1 is 3. And then b, to the third gives me b to the 9th. And for the last time on this video, go ahead, press pause, and try numbers 5 and 6, please. So it's easiest to do this work in 2 steps, showing that you first are applying this 3 as an exponent to the 4x squared, y to the 5th, and z, as I've done here, and then your simplified solution. 4 to the 3rd is 64. X to the 2nd to the 3rd is x to the 6th. Y to the 5th to the 3rd is y to the 15th. Z to the 1st to the 3rd is z to the 3rd. And then doing the same concept here in number 6. The negative 3 is raised to the 5th power. That gives me negative 243. A to the 20th, b to the 15th. Please try the quiz on Canvas for the multiplying properties of exponents.